My name is Krishna, and today I'll be talking about embedding security directly into platform engineering workflows. So, as the title says, we're also going into what are the different kinds of security controls that can be embedded into platform engineering, and this how can this be achieved using policies, and how can we also add monitoring these policies. And as platforms become the backbone of modern cloud applications, it is crucial that we shift left in terms of security, building it right into design rather than thinking about it in later stages. So in today's agenda, we'll go into understanding how can we integrate security into platform engineering. Then we look into some examples of policy as code. Then we look into a policy management service that basically can be used to achieve our goal. And our goal is basically to secure both greenfield and brownfield systems. And then in the later stages, we are going to understand what is real-time monitoring and threat detection, and how can we use some best practices to achieve that. So let's talk about why do we need to embed security in platform engineering. So if you think about it, platform engineering helps teams deliver consistent and reusable infrastructure. But without built-in security, we risk creating scalable platforms which are also susceptible to different attacks. Our goal is to make security a foundational part of the platform and not thinking about it in later stages. So now let's also talk about what are the different kinds of challenges in traditional approaches. So traditionally, security is bolted on in the later stages of development. This introduces delays and friction with DevOps. And we also identify coverage gaps, especially in multi-cloud and multi-tenant environments. And because developers generally lack visibility and guidance in security best practices, if you are able to abstract them and then add it to the platform itself, and then this platform can be leveraged by developers efficiently to build solutions and products on top of it. So this introduces a pretty interesting topic called security by design. So what does security by design mean? Security by design means integrating security controls, policies, and monitoring directly into a platform. This includes automation, policy as code, runtime insights to create systems that are secure by default. Now, to achieve this, we are going to choose policy and use policy as code to automate this. So, policy as code lets us define and enforce security policies in the same way we manage the infrastructure. For example, if we take Azure, we have ARM templates, and using these ARM templates, we basically create different Azure resources. So hence, we are going to use similar kind of templates for policies and then try to deploy this and create a secure platform. And in the case of Azure, it is ARM, whereas in the case of AWS, it's CloudFormation, or GCP, it is Terraform. And in all these examples, they help us apply policies consistently and automate enforcement across different environments. And these policies vary as we go through different verticals. For example, networking, encryption, storage. And now let's talk about how do we achieve this using different examples. So we are talking about a system or a service which is basically going to manage all the baselines and different policies needed for that. For example, uh, let's choose this particular example. Deny virtual machine creation on internet access. So we have created a policy wherein any individual under our under our tenant, wherein this policy will be applied, will not be able to create a virtual machine without closing internet access. So let's say I have the internet access open when I'm creating the virtual machine in my ARM artifact. Then because of this policy, that particular deployment will be rejected by the ARM. So so this kind of policy, before anyone's deployment gets rejected, should be applied at the Azure level. So hence that is where That is where we are talking about this policy enforcement service. So this service is like a storage of all the different kinds of policies, and these policies are articulated and authored and defined based on certain security best practices and baselines. And these keeps changing frequently. So we need to version these policies so that we are aware of what are the improvements that we are making. So these policies, this particular policy enforcement service automates deployment of policies into the cloud. So one such policy that is the one that I showed you, wherein we are going to reject any virtual machine creation which has internet access open. So one part of the policy enforcement services enforcing policies. The second, now, if we talk about the previous slide, wherein we are saying we'll have security by default. So let's understand what does that mean and how does it sit in this whole picture. So on the left side, if you see, I as a user, let's say I want to create a virtual machine, and I might be running an API or a data processing service on top of that. So before I deploy that code, I basically need to create a virtual machine. So I'm going to source code this and automate that virtual machine creation across different regions as a part of CI/CD pipeline. So whenever the CI/CD pipeline triggers, it basically takes these cloud artifacts and deploys it into certain cloud. Now, if you see, the deployment pipeline is the one that is basically sitting in the middle of artifacts and cloud. So whatever we want to introduce should be introduced in this place so that we are able to check consistently whatever is happening before it goes to the cloud. For example, the policy enforcement service should also have a functionality wherein any user or any system is basically able to contact that and validate certain postures with it. So in the case of the example that we are talking about, a virtual machine creation artifact. So before I go ahead with the deployment, I'm going to introduce a step wherein I'm going to go talk to the policy enforcement service, give my artifacts and say, hey, are my artifacts valid and are they good to go to the cloud? Then the policy enforcement service checks whether these artifacts are as per the baselines that are defined. And if it is as per the baselines that are defined, that means it is in compliance with the policies that are already in the cloud. Then it gives a green signal to go ahead and deploy. Once I receive this green signal, then the CI/CD pipeline is going to continue and deploy to the cloud. Now let's talk about the opposite thing. Let's say in my artifact, I have the internet access as open because the policy enforcement service is basically able to check whether if there's a drift or not. Whenever there's a drift, it's basically going to reject. And in fact, because I know why I rejected it, the policy enforcement service is basically going to give back a failure message saying that, hey, you need to add so and so restrictions to your virtual machine artifact. So once the user again makes that change, it again goes and repeats the validation. And this time, because I made that fix, it basically lets me go and deploy to the cloud. And the good thing is, I'm able to validate everything before I go to the cloud. So hence, I'm starting green. Now we have spoken about greenfield. Now let's talk about the brownfield. The brownfield is where we already have certain virtual machines running in the cloud. They are hosting certain APIs and services. So for whatever reason it might be, the particular virtual machine might need access to the internet. So two things over here. First thing is I do not want any downtime. So the key thing in which in the key the best way in which we can achieve secure by design in brownfield is by auditing. So using this auditing, we are ensuring that we understand what is the current posture and what is the drift. And once I understand that, then I'm trying to retrofit the security posture into the existing infrastructure. And because I'm able to audit, I'm able to give certain timelines to the owners of those machines to go and again, because in the previous slide, as I told you, policy enforcement is a service. So the users are able to go validate their artifacts directly with the service, and then the service is going to give back on what are the changes they need to make. So the users or the virtual machine owners are going to use this ability, make changes to their virtual machine before the certain timeline, and in this way they can be secure. Monitoring and runtime. So monitoring is key to detecting policy drift, anomalies, and threats. So in the case of Azure, so let's again go back to our Azure portal and look at that example. So yeah, if you see here, the first this is the example that I just showed you, wherein in the policy I'm just having a bunch of rules and then I'm having a deny action, and I have assigned this policy to a particular tenant. So here, if you see, I tried creating a virtual machine, and when I tried to create it, on the right side, it denied the policy, it denied the deployment because of the policy that I just created. And this is in the case of greenfield. So in the case of brownfield, because the resource is already present, I need to monitor for any policy drifts. So in such cases, if you look at this, if you go to any assignment, it will basically tell you what is the policy drift. For example, here, if you see view compliance, it is basically going to give me an output of what all are compliant and what all are not compliant. Open telemetry can also be used to understand what is the current posture, and this and having this central visibility and incident response ensures that we are secure. Now let's look at some best practices. We need to first start with a strong baseline, and having one centralized platform that is managing these baselines basically abstracts all the security best practices from each individual teams, so that the developers are able to focus on efficiently developing the products. And the second thing is, make sure you use versionized policy repositories, and because similar to code, we need to version control the policies, and we need to integrate this with CI/CD, automate, and this helps us automating policy evaluations. And anything that is manual is not scalable. Hence, we need to ensure that this is automated. And the key thing to remember is security is not just a team; it's basically everyone's responsibility. To secure any platform engineering, we must treat security similar to how we treat infrastructure. It should be automated, it should be scalable, and it should be observable. So by embedding security controls and monitoring by design, we enable speed without sacrificing the safety. Uh, yeah, so if you have any questions about any scenarios, I'm happy to chat with you and try to understand and learn more. Thank you for staying along.